So number 15, we're supposed to determine the end behavior. We can see that we have we have a multiplicity of 1 and we have a multiplicity of 2. If we take x to the first power and multiply it by x to the second power, we get x to the third power. So there's our end behavior model, y equals x cubed. We know it looks like that. And then we would say as x approaches infinity, so as x moves to the right, the y values are getting bigger, so the y goes up. And as x moves to the left, as x approaches negative infinity, the y values are go down. So the y values are getting smaller, and that would be y approaches negative infinity, just like in problem number 14. So to find the x-intercepts, we would set each factor equal to 0. If x plus 2 equals 0, then x equals negative 2. If x minus 3 equals 0, then x is equal to 3. The multiplicity of the factor x minus 3 equaling 2 would say that the factor x equals 3, or the graph would actually touch the x-axis at x equals 3, touch. And the multiplicity of the factor x plus 2 that corresponds to the 0 of negative 2, multiplicity is 1, so we would have the graph crossing the x-axis at negative 2. And the last thing we want to do is find the y-intercept before we start graphing. The y-intercept would be when x is equal to 0, so we have 2 times negative 3 squared. Negative 3 squared is 9, so we have 2 times 9 is 18. So we'd have a y-intercept of 0, 18, x-intercepts of negative 2, 0, and 3, 0. And I think we're ready to start graphing. Yeah, let's go ahead and do that. So the graph for number 15, we said that the x-intercepts were negative 2 and positive 3. Again, the function looks like that. The end behavior is going to go up from left to right because it's a third degree polynomial. And then we're going to go through the graph. What are we doing? Touching or through? So we go through the graph, through the x-axis at negative 2. We're going to touch the x-axis at 3. And then go back up. So both graphs for numbers 14 and 15 look almost identical. Okay, so what I'm going to do here for numbers 16 through 19 on the graphs, I'm going to go ahead and just draw the graph so that, and then we'll analyze the functions on the other side. So this is what we would normally do. We would look at the function, and then we would just go ahead and draw the graph from the function. We'd identify the zeros of 3 and negative 2. We would identify the end behavior, and we notice that we have a negative sign out here. So that's going to change things a little bit. The minus 2, the 2 being a constant, that's never going to be 0. So that's not going to add to the degree of the polynomial. But we can see we have a multiplicity of 1 here, which means that we cross the x-axis at 3. We see we have a multiplicity of 3 here, which means we not only we cross the x-axis at negative 2, but it's with a squiggly. And if you remember what we do there, we'll talk about that in a second. But when we add 1 and 3, we get 4. And so we have a degree 4, and the negative sign, the a is negative, so therefore it opens down both sides. So the degree 4 would look kind of like that. And so we're going to be starting by going up through the graph, through the x-axis at negative 2, but with a squiggly. And then we're going to come down through the x-axis at 3, and we can see that the ends of the graph look exactly the way we said they were going to look. All right, so then number 17, we can see we have x-intercepts of 3, 1, and negative 2 when we set each factor equal to 0. We have a multiplicity of 1 for each one, so when we add those 3 numbers up, we're going to get 3. So we have a degree of 3, and the a is positive. So therefore, the graph is going to go up from left to right. We're going to go through the x-axis at negative 2, through the x-axis at 1, and also 3. Then we have the graph looking like what we said it was going to look like. All right, then number 18, we have a negative a. And then we have a multiplicity of 2 for the factor of x, which means that when x is equal to 0 is an x-intercept, and the multiplicity of 2 means we're going to touch the x-axis at 0. X minus 1 is a factor, so 1 is a 0, and then x plus 3 is a factor, so x equals negative 3 is also a 0. or an X-intercept. Now, when we add the multiplicities of each of these factors, we see 2 plus 1 is 4, and we have a negative, so a is negative and the degree is 4, so the graph is going to open down, and it's going to go down on both sides. X equals, y is approaching negative infinity as x approaches positive or negative infinity as well. So when a graph looks like this, we're going to start low. We're going to start low, go through the x-axis at -3. We're going to touch the x-axis at 0. And then we're going to go back down through the x-axis at 1. And the ends of the graph look the same way that we said they were going to look. Finally, on this one, we're going to go ahead and factor the second factor here. X squared minus 4 is the difference of two squares. So we have an x plus 2, x minus 2, x plus 4. And so what we have here is a polynomial has multiplicity of 2 for this factor. 2 plus 1 plus 1 plus 1, that's a 5. And since the multiplicity is, so the degree then is 5. And the degree being 5 means the graph is going to go up from left to right. Again, since a is positive and the degree is 5, degree is odd, it's going to go up from left to right. So I'm going to go ahead and continue this in the next video. I'm already at 6.5 minutes.